Hey everybody, out in Wonderland, this is Todd DeFore with another episode of HouTube. Today we're going to work on building a cyclorama, a little bit of procedural modeling. I've been doing a little bit of design work recently and realized in the middle of the job that it would be really nice to have like just a default cyclorama. And if you don't know what that is, this is what a cyclorama is. It's kind of a stage where you can kind of set up like an infinite plane. It does capture light. There's a lot of things that make this a really useful thing to have. And back in the day when I was a production assistant, we would rent out photographic studios specifically for this purpose. They use it for green screen and all sorts of stuff. And you get a basic idea of how one is built. They come in different shapes. You can see some are more round than others. Some are just straight walls. We're going to build one a little bit like this, and the big concept here is that there's a radius here, there's a radius here, there's some walls, there's a floor, and we're going to make it so that we can change how much of a radius we have this way, whether they squish and are long and straight or whatnot. So let's get into building it. And you guys, if you have any ideas of how to make this cooler and better and faster and stronger, and let's go for it. So I'm going to put down a basic geometry node to work in, and I'm going to call this build. I normally like working in a subnet, so I'm going to turn this into a subnet by hitting Shift C, and I'm going to call this dev Cyclorama. This isn't all that necessary. It's just house cleaning for me. I usually put a alpha character at the end to know that I'm working on the A variant or the B variant or whatever. So we're going to dive into the build. That's double click or hit I. Lay down a quick subnet. This is going to be our container for our OTL that we're going to make. We're actually going to make two OTLs here. I'm going to supply you guys with another OTL I use all the time. They'll be in a link or it'll be in an email. But okay, so let's just call this Cyclorama, and let's make an OTL out of it. So right click and go create digital asset. I use a specific naming convention. This is in the documentation. Basically, that first part of the name is a namespace. That's what the colons do, and then we call this Cyclorama. And then this will be the versioning. This is all internal Houdini stuff. It's important to remember where this gets saved depending upon what type of platform you're on, like whether you're on a Mac or whether you're on Windows or whether you're on Linux. This path can be different places. So you'll need to know how to install OTLs later, but just keep track of that. That's also in the documentation. We'll hit accept. Now, this cyclorama is going to be a generator of geometry. It's not going to affect geometry, so I don't need any input. So min inputs is going to be 0, max inputs is going to be 0, and if we hit apply, you'll notice that this has a top now, which basically lets users know that this is a SOP that generates geometry. Okay, so we're going to go in here, and if we go back to this, the construction of this, there's a floor and there's a wall. There's also going to be a ceiling, but I'm just going to pretend that the ceiling is a second floor that's just higher. So I want parameters for both. So I'm going to put in, oops, I hit D in the wrong place. I'm going to put in, make some folders to hold our parameters. Everything's going to be based on the floor. So the floor is going to be the main template of the cyclorama, and the walls are going to be attached to the floors, sort of like, you know, the arm bone's connected to the something bone. Okay, and I like the interface here. These are going to be simple little folders. And if we look here, right now I'm going to consider, I like trying my best to make things as few number of parameters as possible. So I'm going to consider there to be a radius of the floor, like from here to there, you know, and the same thing with the wall, from like here to here, and that's going to be considered a radius, you know. So let's start with the idea that there's a floor radius and a wall radius. I am the walrus, so D, we'll put that in here. And this is going to be floor rad, floor radius, and starting value, we'll put in 10. And we'll put in 10 for this one too. Got to give it a name. Oh, not 140, but 10. Okay, so now this is going to be wall rad and wall radius, and hit apply, and you'll see we got that. Awesome. So I'm going to hit accept for now. I'm going to right click this bad boy, copy parameter there, just because I know I'm going to put something down right away. I'm going to start with a circle. So this is going to be, we're going to do this with circles as much as we can. And uniform scale, we'll place this down, relative reference. If I turn this on, ooh, great big yellow thing. Well, don't want that. So this thing needs to be on the floor. And the floor in Houdini, we can see it down here, X and Z. So we're going to make this the XZ plane right there. Okay, good. I'm going to give this 24 divisions because my last name is Do4, and 2-4 is kind of like Do4. Now, if we look at the cyclorama, this is not a closed thing. This is like a stage. So we're going to need an open arc. So we're going to go down here to open arc, and we're going to make this just in half. And if we look, this is the beginnings of a small stage, you know, and that's fine for us. We're going to use a copy stamp technique. Oops, Pete. We're going to use a copy stamp technique to stamp the. And we'll make this floor. And we'll make another circle. And with this circle, this is going to be the walls. And again, this needs to be a polygon. And if we look, I think what we'll do is we'll try the the YZ plane. That makes sense. That it might go like this and like this. So we'll do the YZ plane. YZ. And this is going to be an open arc 2. We can just guess that we'll start with 180. That's not going to work, but we can guess. And we'll just plug this in and we'll see what we get. And, well, not exactly what we wanted. So if we notice, we have what we call an orientation problem. And the way that copy stamp works is it uses N and up to define how to go along this, how to instance or copy these wall splines onto the floor spline. So we're going to need an N, and one of the great tools for this is polyframe. So if we bring polyframe in, you'll notice that that really didn't do much. We have all these different ways that we can calculate an N. Tangent name, tangent U. So let's just use the N. That's not going to work. So let's try this. Let's call this N. Does that work? Well, that's better, I guess, maybe, but not quite. So let's turn that one off. Let's try this one. N. That sort of works, but they're just not in the right. They're not spinning. They're like making a croquet kind of like thing. We want them to be this way. We want them to line up so like if they were rotated. Now we could rotate them here, but we also have this, right? So what happens if we go back to 360 on this, right? Now it's fully round, so we don't want that. Let's start turning this. Okay, so that's the bottom of it, and 270 seems to be like a good value for the bottom. We look right there. That looks like a good value for the bottom. What's this top one look like? So if we go back this way, yeah, it's going to be a nice trigonomic number, like 90, I'm sure. There we go. So now we're starting to get something. And if you remember, so this was our floor rad. I'm going to copy that for now. I know the other one is called wall rad. So I can just paste this in and retype in wall here. Wall rad. There it is. So we just type in wall rad, make sure it's wall rad. And now we got our wall rad. That's a pretty big wall rad, right? And the other thing is it's not really lined up with the floor, you know? So, how are we going to solve that? You know, this thing definitely needs to move up, right? So if we move up our circle, that's it, 10. 10. Those look like the same values. Something tells me I could paste this into here, right? And if we go up now, oops, gotta plug this into the out. That's the out. So if we go up now, and I change the wall radius, that thing locks right in there. So that seems to be a good thing, and we could change this radius and this radius, and that all looks pretty good. Okay, so now we need to make this an actual object that's got some geometry to it. Lay down the skin, boom, got it. Now we've kind of got this issue where, what do we want to do if we want the stage to have a little, we have the stage and we want it to have a little, maybe, like right now it's really round. You know, if we look here, we've got some squareness to it, you know? So, like, if we came in here, tab, transform this bad boy, right? Let's just see what happens if we take our scale and we go, you know, this way. You know, and then what happens if we go, you know, like, what happens if we copy this, paste relative reference, and go like 1 minus that? Well, what happens? So now we got this, the ability to kind of square it up and make it a little bit, you know, it's not exactly square and round, but it gives us a chance to, if we go 0, oh, go 1. Well, that's not good, so that ain't it. I had to think about this for a second. Let me pause. Okay, so let's think of it this way. 1-to-1 scaling gives us a, I'm going to create a parameter here called squish. Edit parameter interface. I'm going to add a little thing right here where we're working. I could put it at the top level, and I probably will at some point. For now, I'm going to call it SQ. Well, we'll call it squish. SQISH, squish. Copy and paste and hit apply. This way it makes me a little easier. So I tried pasting squish right in here, and I tried this. Copy parameter, paste it into here, relative reference, and then go paste it into here, paste relative reference, and go 1 minus squish, and I got that because that turns into 0, and that's not exactly what I want, right? So if I'm 0, that's kind of jank, and if I'm 1, that's kind of jank. That's not what I want. So then I came up with the idea that, like, what happens if I go 1 plus this, right? Okay, so now if we're 0, we're back to these should both be 1s, right? Now as we squish this, we get, let's change this again, edit parameter interface. So we could go 0. I'm going to go -1 on this, and I'm going to go 1 on this. I'm going to lock them, so I can't go beyond where I think things are going to be funky. Apply, accept. Okay, so if we go down this way, we get a stage that looks like this. If we go this way, we get a stage that looks like this. So it kind of squishes and kind of squishes like that. So I think that's going to work for me. I think that's going to be enough for my cyclorama for what I need from it. It's not exactly perfect like the example. You know, the example definitely had some very squareness to it. I don't know how important that is for what I'm doing, but if you wanted to really square this up, I'm sure we could come up with a way. But for now, just being able to squish it so it's not just round is going to be enough for my purposes, for what I want it for like just a generic cyclorama. So let's go up and we're going to give this edit. We're going to go right click, type properties, and in here we are going to float. we're going to add the same thing we did there. It's going to be arranged, they're going to be locked, and it's going to be -1 to 1, and we're going to call this, oops, I have my caps on. We're going to call this floor squish, and we'll call this floor squish. Apply, accept copy parameter, go in here, and we're going to just paste it in here for now. Base relative reference. Okay, so now we've got a little bit of a floor squish, and that's a good thing. The other thing we might want or need is, depending upon how big our stage is, and accept this for now, depending upon how big our stage is, you know, so we're getting, like, we're getting a little bit where maybe our boxes are just a little, like, we might want some control over how many samples there are. You know, like, it's kind of coarse, dink, dink, dink. So depending upon how big our stage is, we might really want the ability to resample in here. Tab, resample. Whoops, why is this being tab, resample? We might want to be able to resample, and I like resampling by, like, by length, like how big something is, which can be quite dangerous because if something's ginormously huge, you're going to get into trouble. But let's see what that looks like, right? So I'm going to edit parameter interface, float, and I'm going to call this floor resample, copy and paste, and range something to 1. I'm going to default this to 0.1, hit apply, hit accept, copy parameter, and we're going to put this right here, paste, copy relative reference. And so now you can see we have this, a nice little resample in here. Oh, type properties, yeah, we have a nice little resample in here. So we can start deciding how rough or coarse we need things to be. But that's good. And I wonder if that should go. That should probably, this should all probably happen. Oops, sorry about this, but the polyframe should really happen after all of this so that we get nice orientations. Now if we look, this is kind of janky too. Like, you can see that we might want some control. Well, I guess that's going to happen later too. So we'll go with that. Now, one thing that we are missing is the idea that this space is open and not closed, and that in the other example we have these nice long kind of things extend out. So this is where we're going to get into building our other OTL, and let's start that other OTL by just putting down a simple circle. We're going to build a second OTL here to do what is called a curve extend, and let's do that now. So hold on one second. So we're going to put down just a regular circle at this point, and again X, Y, Z, and we'll make it a polygon, and we're going to pretend that this is our floor at 180. Okay, and open arc, 180, and we're going to build a new OTL subnet, and we're going to right click on this, create digital asset. This is going to be called D4FX curve extend 1, and in here we'll go 1, and in here we'll go like that and accept. Now this one is going to affect the geometry that comes out of it, and the parameters that we're going to need for this is how far to extend the start and end of a curve. So I'm going to grab this and I'm going to make it 2 inputs, and we're going to call this extend, and probably for now we'll just call it 0 to 1. You're not going to want to go negative, so hit apply. In order to make this look a little bit nicer, I'm going to add a label so we can see something. Put a label up here and a little label right above it. And I'm going to have 2 labels here. I'm turning this off. And the first label is going to be start. Second label is going to be end. Apply. So you see a start and end amount that you can put into your how far we'll extend the curve. And I'm going to turn off Tommy here, hide others. And if we look, turn on point numbers. See, there's 0. That's the start of the curve. That's the end of the curve, 12. So we're going to make something that's going to make 0 go further and 12 go further out. And just like before, we're going to need to find out what the normal direction of these guys is. So I'm going to turn on normal. So right now we don't see any. If we middle click, there's no normal. So we'll put down a null here just to have something that's just like kind of the input that we can middle click on. See, no normal. So we're going to need a normal. We're going to need some sort of vector that tells us what direction to take this out on. So in comes our good friend, the polyframe. And so now we have normals, but that's not the normal I want. So I'm going to turn that normal off and just try this one. And what's that give me? Well, that does give me a normal. So if you see off as the 0 point, we're going out the way we want to go. But this one is not going out the way we want to go. So that one's going a little bit different. So the next thing I'm going to want to do is I'm going to want to find out how long this thing is. So we're going to measure this. Put down the measure stop, and we're going to check out, not tape measure, just the measure stop. And we just need points, we need a primitive. And if we middle click this guy, we should have a perimeter value. Great. Negative extension, right? It's possible. That's what this measure stop was for. So let's take a look at the idea of extending something backwards, right? So there's a function called the carve stop, which can be quite good. And if you look, this would make it go backwards if we had a negative value, or the same thing if we had negative value on this side, right? So let's see, this is the 0 curve, right? So this is the start and this is the end. So if we go up here, this is the start. We'll start with the start. Copy. And I kind of know this expression, so we're going to go fit. If we fit how much we're moving by, paste values, paste relative reference, by between 0 and how long the perimeter is. So we're going to go prim of our input, prim, I think it's the string, what it is, so // measure. And what do we want to get? We want to get the perimeter, and we want to get the 0 value of that. And we're going to want that to and this is going to be and this should be perimeter also. Perimeter. So it should be the prim of the perimeter. And this is, I think this is supposed to be negative. Oh, this is not extend 1. This is CH. Oh no, that is extend 1. So the channel between extend 1, perimeter, and that gives me 0. Pause this again. We should, if we go up and I go negative, we should see, that. Oh, we locked it. So we made it so you couldn't go negative. That was smart of me. So let's just make this extend. We won't lock it, so hit apply. So if we go negative now, we should see that shrink, and there it is. So that shrinks. So now all we have to do is do the exact opposite. So instead of 1, we'll go 2 here. So now this will be 2, and we'll double check it. Oh, and this should probably be 1, 2, 0 maybe. And if we go up and we go negative, yep, and then it eats in and that shrinks it. Okay, so now that we've got it so they can go backwards, excuse me, by percentage, let's get it to go forwards. So put down a little attribute wrangle, and we're going to do a little bit of attribute magic. So this will be extending it. So this will be reducing it, the curve, and this will be extending the curve. Extend. So we're going to need a couple of values. Float. My extend start is going to equal ch, and it's going to be dot dot slash. I think up here we had that value. That this was in here. That's this. So copy this. It'll work the same way in here. Paste. So that gives us the parameter at the top level of the OTL. And we'll do the same thing here. 2. This will be extend. So the start, and then this will be the end. Okay. So if my extend start is greater than 0, that means we're going to definitely extend this. It's got some values and which point we are. So at point num, and this is going to be the start, so equals 0, and my point number equals 0, then we're going to do something. And what are we going to do? We're going to make at p plus equal extends all the way out, just like we expected it to. That is great. So now we just got to do the same type of logic. We can almost take this entire block of code, copy it, paste that entire block of code, and just do the same thing. If the end value of extension is greater than 0, and now this is a little bit different because it's going to be if point number, this code is a little bit different. This is going to be if point number equals, and I'm going to put these in parens too, and this is going to be at num pt minus 1. The total number of points minus 1 should be 12, because the total number of points is 13 because it starts at 0. Then it's really going to be that p minus this, because the n is going, if we look, this n is going this way, so we need to subtract this amount from here this way. It'll make sense when we see it. You can trust me. I can trust myself, I hope. Let's see, does that extend it? Yep, and that extends it. Okay, so now we have a legitimate curve extender, which is great. So we don't have to keep writing that code all the same time. There's a good reason to have OTL. So we're going to save that node. We're going to match current definition so that we have a nice clean curve extender. And we're going to use this in our Cyclorama tool. So we do know that it extends a curve. Let's look where we are here. It looks like the same curve. It's actually not. We're in somewhere different. I'm going to paste that in here, right? And if we look and we extend this a bit, we should have seen that move. So let's go in there and take a look. I know exactly where it is. I forgot right here to change this to an E. And that was it. So now I can save this, save node type, match current definition, and that bug should be fixed. So now if this is negative, it goes negative, positive is positive. I'm going to take these values, I'm going to zero them out real quick, and I'm going to, on my floor, I'm going to, on my OTL here, on my Cyclorama, here, I am, ooh God, that looked ugly. What is all that? That nasty. What happened there? Output. Resample, polyframe. Resample, polyframe, copy stamp. Got another bug. Hold on. Floor extend, right? And I'm going to want these two values to be up on my OTL. So one of the things I sometimes do is we're going to go up and go type properties here. Type properties. And on a Mac, I can, on a Linux machine, I can go keep on top. I don't think I can do that on a Mac. So like if I dive in here, oh, it stayed there. So I'm going to take these guys and I'm going to just drag them up there and hit apply. Destroy all, cancel. Type properties, go in here, and this extend, and we'll call this floor extend. And let's see what that does. Except if we go up, we should be able to extend this floor. See, there you go. So now we've got a stage where we can extend the wall of the cyclorama, which is nice. So we can copy and paste this, copy this, and paste this to the other side, relative reference, and we should now have a floor that extends. Super dope. Okay. And if we look, I think floor extension, resample. Why is the resample upset? Oops. So there's a resample. Oh, that's why it's upset. So type properties, I put put a float here. So copy this. This should never be 0. Let's at least make it 0.1. Copy that. In here, paste, copy relative reference. Oh, I already knew. All right, so now you've got even spacing along this extended range of the cyclorama. So it's starting to become a little bit more like what we were expecting, except the floors are not closed. Let's try adding. Let's go back up here, type properties, and we might take these guys and drag this up into the wall extension, and we will call this, and I think these should probably default to 0, but change that. And we'll call this wall extend and wall extend apply, and that should be pretty good. So now let's take a look. We really need to close these, and we're going to do the same thing with point numbers. Point numbers can be our friend. Hide others. Dink dink. Something we're seeing here that we shouldn't be seeing. But all we should see is this, I would think. That's only one thing. Sometimes Houdini gets a little bit. Hide others and put down a sphere real quick. Look at the sphere. Turn off the sphere. Delete the sphere. That seems very curious to me. Okay. Who knows? That was weird. Okay, so we're going to look at this wall, and if we look, there's a 0 point and a 12 point, right? So we're going to want to figure out okay, yeah. So we're going to want to figure out what the ends are. So the end for us right now is, we might not ever know how many points there are here in the extension. So let's do something like this. We're going to group points. We'll call it ends. Right? Let's do this, and we're just going to say the base group is going to be 0. What does that give us? Right? That gives us that guy. So I think what we're going to do is we're going to go like this. We're going to sort, and we're going to reverse the point sort. So now we got that guy being 0. So now if we go like this, skin everybody, we know that this point here at the bottom is going to be in a group called ends. And I think if we go wrangle, attribute wrangle, and we do something like get group ends, and we're going to need to know something. So we're going to put these guys in the middle of the bounding box, the Z bounding box. So let's take a look here. We're going to cheat, and we're just going to put it on Z. Big. We're going to put it right there on Z. I don't know that we could just put Z equals 0, but let's try this. Okay, so we're going to go like this. Vector my min, my max, and then we're going to go get bbox, this guy, this piece of geometry, my min, my max, and then we're going to go at p dot z equals the max. Oh, that's not true. It's going to equal my max dot z. My max dot z. What does that do? Boom. Oh, I see what it does. It pushes everything to the it takes all of these points and pushes them all the way out to their maximum bounding box. So that makes a lot of sense. So now if you see, all of these points are pink, 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 pink. Right? So you see, they kind of went from their last point to just slam out to the furthest Z you can. So we could do the same thing with the top also if we wanted to, where we take all of these points along the top and slam them out to this edge of Z. We'll just need to add them to the group. So we might want to do that, or we might want it to be open. The thing about keeping it open is that if we put a light up here, the light shines down in there, right? The other thing that we might want to do with our cyclorama, right? Again, this is the cool thing about with our extends is we can take the start of the cyclorama and the end of the cyclorama, and we can see what we can do here. We can shrink it. So we could be like, yep, we're going to pull this back till it's just, till it's straight like this. And that can be our cyclorama halfway up. Go back around, extend it out like this, and then we could shrink everything. Same thing we could have done. Then we can definitely take, and if we've taken this and extended it a little bit, you notice that what ends up happening is all of these points end up being kind of slammed right into the edge here. Although I do kind of feel like we could have done the same type of resampling. Copy, paste. Could have resampled after the extension there and gotten a. The only thing about that is then, yeah, I don't think that's a good idea actually. So let's do the same thing here. We're going to want to be able to have a control whether or not we close the top or not. So that's going to be an on or off. So let's get ourselves a nice little toggle, and we'll toggle top. And I think by default we'll be not toggled on. So hit apply and accept. I'm going to go up here. I'm going to copy this guy. I'm going to put in a switch. And all we're going to have to do is we're going to have to, if we remember this extension, the 0 point is up here on top right now. So we can do the same thing here. I think we can just plug this guy into here, this guy into here, and that should give us an ends on top. And if we take this and instead of replace, we go union with existing, then when we do this, let's toggle the top on, we should see both of these are in the group now. And that being said, when we go to close this, we get a nice little close like that. Now, one of the things that happens is if you look, we get all this super janky geometry, lots of long splinters and things that are kind of not the best, to be honest with you. A friend of mine, Kevin Gillen, wrote a tool once. It is phenomenal, and I haven't asked his permission to hand it out to everybody, but knowing Kevin, he probably wouldn't mind that much. And that tool is called Rebuild, and I appropriated it when I worked with him. And Rebuild is awesome. This tool will be available to anybody who's asked me for it, or I'll put a link in the video description. Hopefully you can get it. And what this does is if something is a mesh, it will rebuild that surface to a certain size, which is super cool, or a certain number of divisions. And let's give you an example. So like right now, these things are polygons. If you look up here, they're primitives, they're polygons. But if we went to the skin and we said, don't output polygons, we now get a mesh. And meshes are awesome. It's one big piece of geometry now. It's one primitive, and it's a great big mesh. The thing that makes a mesh so great is it becomes carvable. You can use the carve tool on it. You can use the carve tool on it, carve it up, just the piece you want. And this will become important a little bit later in some of the stuff that we're doing. You could carve just sections of this that you want. It becomes very powerful. So I'm not a big fan of skinning things into polygons if you can keep it a mesh. It also makes it so we can plug it into this tool. And I love this tool. And I think the way that I'm going to do this is by division size, which can be dangerous at times. Or maybe that should really be yeah, I think we'll do division size, and we're going to keep them the same. So this will be division size, and this will be division size, and we want them to be the same size, so they end up becoming squares. So paste relative reference, and we'll make the size pretty big for now, like 0.5. If you look, all of a sudden our piece of geometry it's getting smooth again. And if we look at how janky those long triangles were, they're getting all nice. Oh, turn on smooth interpolation. There's a button here called smooth interpolation. And we don't care about passing through the breakpoints. We just want it to be smooth. And if you look, we're kind of auto-magically getting some pretty nice, like everything's getting nice and squared up. Oops. Now this is a little bit funky. And maybe that's from the, did we extend that wall? Yeah, we did. We extended the wall. So if I turn the extend walls off, that probably is going to go away. Let's look. Yeah, that went away. So, yeah, that's pretty good. And now if you look, and we're in here, and we turn off this, we just go smooth shading, you can start seeing, you get this kind of like space that is kind of a sort of infinite, right? Which is exactly what we want. We've got this nice stage. Let's turn Mr. Show All Objects. We'll put him back in there, right? So now he's in this kind of like almost infinite, like the lighting gets it to the point where it's starting to become very, you know, kind of studio lighting. You know, if you were in here and you were like, yeah, it gives you a very studio-like environment to work in, you know, in terms of your backdrop and your rendering. So, that is the cyclorama. I plan on doing another tutorial next week about how to really utilize this cyclorama to do some kind of interesting motion graphic like effects. So again, we'll just kind of sit here real quickly and just be like, we can change how tight our cyclorama is, how much we squish it, squish the opposite way so it's more of a open thing like that, how big our wall radius is, also how much we extend our floors, you know, oh, that's floor radius, sorry. How much we extend our floors, you know, do we extend out? Do we keep it pretty much just a big round blob? And again, if we remember this, we can carve these things. So interestingly enough, I haven't done this in quite a while, but if I carve this like this, and I copy and paste this carve, if I remember from a long time ago, and we go kind of the opposite of this. We can go copy this, paste this into here, paste relative reference, and do 1 minus. We should get, that's the top, that's the bottom. Actually, let's do, so let me see this one again. If we carve this down to like, oops, something like that, and then you get that. Okay, yeah, that's right. I think there is a way of, if we go to NURBS, I think there is a way to connect those two. Let me try this. And if we take this guy, and we'll shrink him down to, oops, now we're looking at this guy. So we'll do the second U, and we'll go all the way to the top. Merge. It had been a while since I've done this, but the great thing about a mesh is if I plug these two meshes together, now I've got two meshes, and if I put down a join, tab, join, what you will notice now is that boom, now we're starting to get a little bit, we can get a little bit more like that kind of square. I'll put this up. My Mac is really not happy about this stuff. So we'll go flat wire shaded so we can kind of see. Now again, you can kind of see that we've got this a little bit of a janky little, you know, the isoparms are not well balanced, but you see it joined them up real nice. And if you wanted a really nice kind of harsher edge in this radius, we could get that by fiddling with our wall radius. So you can see we're getting a little bit of a wall radius, and it's getting a lot tighter. And easily enough, we put down a transform stop here. We can move this guy up, you know, move him up, and this wall radius did get a little bit tight, and go 4. And so you see it got joined, and if we look here, we should have one mesh. So let's see if putting down my friend's handy dandy rebuild tool, which basically rebuilds a mesh, and we'll go division size again, and we'll go division size again, and we'll put this at 0.5 and copy parameter and paste in here, paste relative reference. Here we go, hidden flat wire shaded. Yeah, there you go. See, you get this really nice, go smooth interpolation. Don't worry about passing through the breakpoints. And now you get this nice, really like now his world is completely very, very much a big blank space. You know, like turn the just a smooth shaded, and you know, now he's in a little bit more of a squared off kind of cyclorama world. So that should do it. We're almost at an hour, which is twice as long as I really wanted this to be. Hopefully you guys learned some stuff. Again, sorry for jumping here and jumping there and having a few bugs along the way. If anybody wants the OTLs that were made here, let me know. Email me. As always, you can go to, hold on,